multiply monomials, we need to break this down and see what's actually going on in the problem. The first monomial can be written as 3 times x for the x squared and times y for the y squared. We're going to multiply that by a second monomial, which has a negative 2 as a coefficient, times 1x, and then 3y's. We can use our commutative property of multiplication and rearrange this so that our numbers are together, our x's are together, and our y's are all together. Then we can simplify this back down by multiplying the 3 times negative 2 for negative 6. Writing the 3 x's multiplied together as x cubed, and writing all 5 y's together as y to the 5th. Now, if we look at this and see what's going on, we can see that actually what we did was we just simply multiplied the two coefficients, 3 times negative 2. To get our exponents, we had 2 x's from the front, 1 x from the back, an understood exponent of 1, and 2 plus 1 is 3. And we had 2 y's from the front and 3 y's from the back, and if we add 2 plus 3 we get 5, seeing our 5 there. So now let's look at a couple of them where we just use the rule instead of trying to break it all down. Let's take a look at x to the 4th power multiplied times x to the 5th power. Well, our coefficients are simply 1, so 1 times 1. And for our exponent, we're just going to add 4 plus 5. And so we end up getting 1x to the 9th power. And we know we don't really have to write the 1, so it's simply x to the 9th power. Let's look at one more. Let's say 3x to the 5th power multiplied times 2x to the 7th power. Once again, we're going to use the same procedure. 3 times 2, and for my x, it's going to be 5 plus 7. So we end up with 6x to the 12th power.